RDP8. They're also using UDP now. VMworld2013 were the first to use UDP, and now Microsoft is also UDP as the default session. If you have a big enough pipe that like 100 users can connect to your central server using 100 megabit, that is the kind of performance that we get there. So almost not comparable if you look at the upper two video. So sometimes it stutters, it buffers, there's still some room for improvement, but the two are getting very, very close. Well, all three. You see RDP8, lower right side, pretty much the same. So that's good news, and because QuickTime runs smoothly on the right side, and it doesn't run that smoothly both upper left and lower right. And it doesn't run at all with RDP 7.1. And that was if you have enough bandwidth. Now, if we reduce the amount of bandwidth, as you can imagine, it gets even worse. RDP7 is really struggling. The others are also struggling, except for Citrix, redirected flash. So now you get the idea what it means if you redirect one of those graphics formats. However, if the client does not have a built-in flash play, they also have to fall back to host-side rendering. And from that very moment on, the Citrix performance is pretty much the same, like you have with Vue or with RDP8. So that's not a big difference. Let's take a look at WPF. 2 megabit, 50 milliseconds. That's an application that Shawn actively contributed to. I mean, it's where you can, it's a media center software. And the tricky thing is that they have picture transitions. And you see, Vue is using a little trick. It does not do these smooth transitions because they are really hard to encode. They're smart enough to find out, oh, okay, if I do this transition, my performance will not be so good. So I just switch from one picture to the other, while the others are trying to be as accurate as possible, but then they're stuttering. So again, you can either have one or you can have the other. It's up to the user, what the user prefers, or you as the decision maker who is introducing this technology, what you prefer. It's both usable. You get used to it. So, let's see Fishbowl again. With that configuration, also Vue presents Fishbowl in red color. I'm going to show you a scenario later where Vue is the only one that is able to render blue water. But you also see the difference in the algorithms. While Microsoft is more like, okay, let's do it slow, let's do it really slow, make sure it's all very accurate. Vue is more like, so as I said, both is absolutely, well, is feasible, and but it's a little bit different, you see? Now, if people think that only high-end graphics applications produce, well, challenging output, this is not correct. Applications, the video player is one application, but still, elements of the video player are rendered on the host side and other elements are rendered on the client side. If you move around the window quick enough, sometimes you see that they're disconnected. So the video tries to keep up with the rest. You know that from TV cards. They do pretty much the same. If you have a TV card and a PC, they also do the same. They inject the video image directly into the frame buffer instead of rendering it in a traditional way. So that's pretty much the same. So as soon, and I know that VMware new 5.3, they introduced video redirection. So you can expect much better results now with the new 5.3. We didn't have an early version, well, we did not have the final version early enough to do the same sort of tests with new 5.3, so it's new 5.2. Good. Now let's go back to the slide deck, because now we want to move into the final comparisons, and that's 3D. So we've done that. Let's go there. And who of you has attended the NVIDIA session on Tuesday? Okay. So in the session, Will Wade, he introduced how NVIDIA does that. So some of the stuff is repeated here, but only on the very lightweight, because I want to show you the results. What we did in the last test is this software rendered graphics for task workers. So as soon as you go up this pyramid of users, you want to have more graphics power. And there is this graphics acceleration guideline from VMworld. Some of you may be aware of that. So it says that soft 3D is good for task workers. As more as you go to the right side, you'll find out that you need more graphics power. And so the software rendering is not good enough. So there is the soft GPU. There is something that is called VSGA. VSGA. So the acronyms are really complicated because every vendor uses a different acronym for pretty much the same technology. The components in there, in the hypervisor in particular, we want to take a look at the graphics adapter. Then we have the guest operating system and the virtual drivers in there. We have a VDI management on top, which is viewed, and we have the remoting protocols that allows the client to communicate with the VMs. Fine. Now we do GPU sharing. That means we have a physical GPU in the box where the hypervisor is. So your ESX box has an NVIDIA graphics card. We have to install a driver that allows us to use the graphics card, but then the virtual driver has access to that physical GPU. But it's shared because it's shared among all the different VMs that are available on the system. So this is what GPU sharing is about. The tricky thing is, which graphics formats do your virtual drivers support? And this is what VSGA supports. So you see the OpenGL versions that are supported. Not everything is supported, and sometimes you see, it's partially supported. Later you will see a video that clearly shows you what the effects are if it's not completely supported. Then we have the other method. It's called pass-through, which was introduced to the public this Tuesday during the keynote. So what it does is it uses the physical hardware, but you are able to install a vendor-specific driver in the VM. And you assign one GPU to that VM. So this is the trick. Now you have multiple GPUs, physical GPUs, on your ESX server, and you decide this VM is going to use this GPU exclusively. Okay? So that's the idea here. As you can imagine, this provides the most performance because it's exclusive access to a high-end GPU. For our tests, NVIDIA was kind enough to give us GridK2 cards. A GridK2 card comes with 2 Kepler GPUs. Each GPU has like 8 billion transistors. So it's higher integrated, it's higher density of transistors than you have on your CPU. So it's a masterpiece of work. So they say that for every billion transistors, it requires $1 billion to produce it. So that gives you an idea how much they spend on the development of this Kepler GPU. It's the one that you also get in the high-end gaming cards now. So a RIP K2 costs roughly $4,000 these days, and it comes with 2 Keplers. The K1 comes with 4 Keplers, but they are lower density. They are the entry-level Keplers, while these are the high-end Keplers. We had to buy new cases because it requires some extra, well, fans and fan control and big cards and power supply and everything. So it's really tricky to play around with them in a lab environment. But it's great stuff. Now this is what they look like. In front you see the K2, back you see the K1. Now, let's use that to compare stuff. Let's do some more challenging demos. Like you see here, roller coaster. It's a soft OpenGL application. It's interesting to note if you look at the frame rates. Okay, again, upper left is View 5.2. Upper right is Zen Desktop 7 Application Edition, because that's the only flavor of Citrix technology that allows you to share the CPU and the GPU. If you use HDX 3D Pro, it's dedicated. So we did not want to compare a dedicated GPU setup with a shared GPU setup. Lower left, it's Windows 8, RemoteFX, using the same Kepler card, and on the lower right, it's the reference running on bare metal, using an i7 bare metal system. In this bare metal system, we put a K5000 card, which has the same Kepler GPU like the K2s. So it also uses one of these high-end Keplers. The lower right is the maximum we can get. That's the top performance that we can get using the same kind of hardware. And as you can see, particularly on the LAN, it really performs well. Now, the counting of the frames, hey, don't care about that, because it's about how many frames can you push through the network. Sometimes they count the frames that they render in the frame buffer, and sometimes they count the frames that go through the network. So don't get confused by these frame numbers. Okay. The PowerPoint thing. On the LAN. Look at that. All of them start being very, very close to bare metal. It's amazing what you can do with that. Now we're going to take a look at a little bit more challenging stuff. And you see here, OpenGL. Oh, that's a DirectX demo. High-end DirectX. Unfortunately, Vue does not support DirectX 10. I think it's a DirectX 10 application. So the others can do it. You can't do it if you with a shared GPU. You could do it with a dedicated GPU, because then you have the native driver. And the native driver supports that for obvious reasons. But you see, sometimes even Microsoft can do stuff with DirectX 11 that neither VMware nor Citrix can do. Just to give you an idea, there's nobody out there who can do it all when you use remoting technology. Just want to send out that very clear message. Here you see OpenGL Domino. Here the Microsoft guys can't do it. They really suck with OpenGL. And here you see, yes, it's kind of supported. They're working on it. So, but you see, step by step, they're getting it. I bet if we do the same test with U5.3, it's going to work. So never take it for granted if they say, hey, yeah, we can do OpenGL. what the performance looks like on the network. And here you see, wow, for the first time we see blue water. VMware is the only player in this game who can render blue water with HTML5. And fish are moving nicely. Look at that. Yes, it uses more bandwidth, but it looks good for the user. It's exactly what the user expects. Here you see new rocks. Roller coaster. Same thing that we've seen before. Here you see HDX, RemoteFX on the right side. They are counting the number of frames they render in the frame buffer, while Teradata VMware, they count the frames that go through the network. Performance is pretty much the same. Do not trust those frame rates in some of the benchmarks for obvious reasons. They were not designed for benchmarking remoting protocols. They were designed to benchmark local performance. Different story. And the PowerPoint animation also gives you a good impression that there may be spikes in the network performance in order to perform well. You see, I mean, VMware uses a lot of bandwidth in order to create the same user experience like Microsoft does on the right side. But you also see the effects. Microsoft is really struggling here, while the performance is really well on the user side. So the vGPU implementation for Windows 7 in particular does not really work so well. So, as I said, the stack, Microsoft modified the stack in Windows 8. So Windows 8 performs really well here. Windows 7 with the add-on, with the backported protocol stack, no, this is the kind of performance that we get. So, final examples. Let's do the same thing. Let's do it on the WAN. Google Earth. 8 megabit, 50 milliseconds. Again, bare metal, lower right side. This is what we want to get. And you see, here, View is doing a great job. So it takes a lot longer until Citrix catches up. The quality is better on the View side. Microsoft here, down there on the left, lower side, is struggling with that scenario. So very obviously, View looks good with Google Earth. So there are some times when it starts, you see the buffering kicks in. Different algorithms. And let's do the roller coaster with 8 meg. And with OpenGL, you see that it's quite significant that Citrix is doing better. So the better performance we had with the Google Earth on the View side, now we suddenly have a better performance with that OpenGL rendering on the Desktop 7 side. As Cindy said, you cannot have it all. You have to make up your mind. It's about the choices. Good. The final thing that I want to show you, because as I said, we were not able to record the direct VTGA results, but I have here a benchmark where we use HDX 3D Pro, lower right side. Up here is bare metal, just doing that on Intel Core i7. On the right side, up here, it's the same machine but with a K5000, which is the Kepler GPU, high-end graphics performance on the client side, bare metal. Down here, shared GPU Microsoft flavor. Down here, HDX 3D Pro. Now look at the performance. The bare metal without graphics acceleration cannot keep up with the remoting technology. So lower right is what we get from the cloud if the host has a GPU that is powerful enough. And we play it back on the same machine like we have up in the upper left corner without graphics acceleration. So now for the first time we have a demo where the cloud, the remoting beats bare metal. That happened about half a year ago. Now after the announcement on Tuesday, I expect VDGA to perform pretty much like HDX 3D Pro. That gives you an impression where everything is going to. So this is very interesting. Now we are able to beat bare metal from the cloud. It's really interesting. Okay, final words. We require more than 2 megabits. We are head-to-head with the remoting protocols. Pass-through GPU offers advantages in scenarios that require the high-end graphics. So it's very important that now it's possible to assign this GPU power to individual user sessions in a very simple way. So we've seen that in one of the keynotes. In the future, it may play a significant role. The question is, are we going to do 3D design in the cloud now using that kind of technology? I believe that prices for the GPUs will drop dramatically over the years. So it's only going to be a couple of $100 that we have to pay for a high-end GPU if we put it into a data center. And so you will get it like for $5 or $10 per month if you want to use a high-end GPU, which is good news. So we're going to use this desktop as a service thing, even for high-end graphics. If we continue doing the same, if research and development continues at the same speed as it does today. Okay, I hope this gave you an insight into what's going on with remoting graphics. I'm here to take your questions. Anybody who wants to go to grab some coffee and go to the next session. Thank you very much for attending. Built-in codecs. So most of the times the hardware for thin clients and zero clients is the same. The only difference is on the thin clients you have the HDX and RDP7 clients, while on the zero clients you have the PCoIP client. That's the only difference typically. If you go to Samsung or one of those vendors, you will find out it's exactly the identical hardware. Depending on the protocol stack that they have on the zero client, it will work or it will not work. The host can do it. The question is, does the thin client or zero client vendor ship the product with the latest version of the PCoIP client? With what? Ah, you want us to include a link test. We did not, but Link is a very good example. More and more customers are using Link within remoted desktops. That's going to be one of the next tests that we want to do. Yeah, I know. More questions?